We move on to the next number. A ray of monochromatic light passes through the glass prism shown in figure 6.1. 6a. State what is meant by the term monochromatic. The answer to this question is the same as before, which is light of one wavelength or light of one color. Question B. State the name given to what happens to the ray at A. For this question, you are allowed to answer in only one word because it is about state the name. But use the word refraction instead of refracted because the problem asks the name of the event, not the event itself. Question 6c. Use the values on the diagram to calculate the angle of refraction at A. The angles in a triangle add up to 180 degrees. To answer this question, we have to go back to figure 6.1. Look at the right angle triangle here. This is the right angle triangle. The angles in a triangle add up to 180 degrees. Because this angle is a right angle, which is 90 degrees, and this angle is 61 degrees, then we can calculate the refracted angle or the angle of refraction. This is the angle of refraction. Remember, the angles in this triangle add up to 180 degrees. That means this angle plus this angle plus this angle must be equal to 180 degrees. So, the angle of refraction can be calculated as 180 degrees minus 90 degrees minus 61 degrees, which equals to 29 degrees. So the angle of refraction equals to 29 degrees. Question 6D. Calculate the refractive index of the glass. To calculate the refractive index of the glass, we will use the Snell's equation. N2 over N1 equal to sin I over sin R. N2 is the refractive index of the second medium, N1 is the refractive index of the first medium, I is the angle of incidence, and R is the angle of refraction. To know the values of each quantity, we have to go back to figure 6.1. In figure 6.1, we can see that the ray of light comes from the air into the glass prism. So now the air becomes the first medium, while the glass prism becomes the second medium. Then N2 must be the refractive index of the glass prism, while N1 must be the refractive index of the air. Because once again, now the second medium is the glass prism, while the first medium is the air. So this is N2 and this is N1. N2 is unknown. This is the one that we have to calculate. N1 is 1. Remember, refractive index of air equals to 1. This is the angle of incidence. So the angle of incidence is 45 degrees. And this is the angle of refraction. From the previous calculation, we know that the angle of refraction equals to 29 degrees. Now, let's put the values of the quantities into our equation. N2 is the refractive index of the glass prism, which is unknown. N1 is the refractive index of the air, which equals to 1. The angle of incidence is 45 degrees. So this equals to sine 45 degrees over the angle of refraction is 29 degrees. So now we have N2 equals to sine 45 degrees over sine 29 degrees. This equals to 1.46. This is a round-off number. So, the refractive index of the glass prism equals to 1.46. Refractive index has no unit. So, this is the answer. Question 6e. Explain why the ray does not emerge into the air at B, but does emerge at C. The angle of incidence at B is larger than the critical angle. So, total internal refraction occurs at B. While at C, the angle of incidence is less than the critical angle. Therefore, the light is refracted at C and emerges into air. Question 6f. An identical prism is stuck to the first prism using a transparent adhesive with the same refractive index as the glass. This is shown in figure 6.2. On figure 6.2, draw the path of the ray after it has reached B and until it has passed into the air again. On the boundary between the two glass prisms, nothing happened since the two mediums have the same refractive index. The ray of light will pass through this boundary as a straight line. So, we will get this line. This line is just the extension of AB. On the other side of the glass prism, this side, the ray will be refracted because it passes through two different mediums. Initially, the ray comes from the air into the glass prism and comes out of the glass prism into the air. So, the emerging ray must be parallel to the initial ray, which comes into the glass prism. Then, this is the emerging ray. Once again, the emerging ray must be parallel to the initial ray, this one. Then you will get the correct drawing.